Determine the inverse Laplace transform of some S-domain function using the Stanley method. Here is an S-domain transfer function. It has an S-domain numerator and an S-domain denominator. The Stanley method always produces one of the following for each pole of the S-domain function. It could be an exponential function with a time constant of 1 over b. It could be two exponential functions with a time constant, each one with a time constant of 1 over b, and one has a ramp multiplier. It could be a sine function modulated by an exponential function. The time constant of the exponential is 1 over b, the radian frequency is omega, and the phase shift is g. And there are constants multiplying each term. Here are the only possibilities in this course. There are three time domain functions based on non-repeating real poles, based on repeating real poles, based on complex conjugate poles. These are all real numbers. T is the independent variable, in other words, the horizontal axis of the graph. F is the dependent variable, in other words, the vertical axis of a graph. To summarize, the denominator has only three different factors that results in three different poles. Only three time domain functions can occur, one for each pole or pair of poles. What are the poles of the S-domain function? The TI-89 seesaw function will find the poles of F. The poles of F are also the roots of the denominator, which could have been determined by inspection because the denominator is already factored. Closer inspection shows two poles at s equals -5. We have one real pole, which means that we need one of these terms. We have one pair of repeated real poles, which means that we need both of these terms. Note the appropriate notation shifts. C becomes E, and B becomes D, and A becomes C. Therefore, B equals 13, and D equals 5. And now only A, C, and E remain unknown. Determine A. The pole associated with this term is s equals -13. Multiply the function by the factor from which that pole came, which will cancel that same factor in the denominator. And then evaluate what's left at the pole. Now determine C. The pole associated with this term is s equals -5. Multiply the function by the factor from which that pole came, which will cancel that same factor in the denominator. And then evaluate what's left at the pole. Determine E. The pole associated with this term is s equals -5. Multiply the function by the factor from which that pole came, which will cancel that same factor in the denominator. Take the derivative of what's left with respect to s, and then evaluate that at the pole. We have thus found the inverse Laplace transform of the function using the Stanley method. What follows is a way to evaluate C and E using the calculator. First, calculate C. Enter this function into the function editor. Then evaluate the function at the pole. Then calculate E. Calculate the derivative and evaluate at the pole, all at the same time.